In today's video, I would like to show you how we can determine the concentration of analyte in a sample using calibration curve that plot with absorbance as a function of volume. Okay, instead of in x-axis as the concentration, which we have covered in the previous video. Okay, if we choose to plot the calibration curve with this unit, okay, first of all we need to find what the mathematical expression that represented all the individual points, okay, all the individual points in the calibration curve, okay, individual points of standard solution in the calibration curve, where these data points of standards can be represented, okay, by this equation, where all these symbols, okay, in this equation carry the same meaning as the one that we have covered before in the previous video, okay, where the whole thing here. Okay, the next step, okay, what we need to do is we want to simplify the equation by assume that this expression is represented by the k value. Okay, so this is the new equation, and this equation, okay, if you compare with the expression y equals to mx plus b, where x in this case is the volume of standard and the y-axis is the absorbent unit. Okay, so from here a is y, okay, and for the expressions of MVS, okay, MVS actually refers to the this expression. So from that we can generate equation form where M actually equals to KCS, okay, because okay, KCS, and then for B actually is equals to this expression. Okay, for the next step we will rearrange, okay, we will arrange the equation 4 in here and okay, express the expression with the K equals to M divided by CS. Okay, after that we will substitute this equation, this expression into the equation 3. Okay, and from that you will generate a new equation we call as equation 5 in here. Okay, so this expression is the one that we use for the quantification. Okay, so now I will show you how we can apply this equation, okay, using exercise examples of this one. Okay, so what we need to do is okay, from the data here, okay, we put all the required unit. For example, in the preparation of seal of standard, okay, what the volume of what the added standard volume, and then their corresponding absorbent, measured absorbent. So and then doing the same thing, okay, you will plot the calibration and we get here, and from the format trend line, okay, you can display automatically the equation and also its correlation coefficient value. Okay, as I said in previous class, it's wise, okay, to double check whether this slope and intercept, okay, is correct or not. Okay, so simple. You can calculate the slope. Just go to function and find the slope function. After that, highlight. Okay, you want to find slope for x and data sets of x and y, which in this case volume and absorbent. Okay, using the similar way, okay, just using the function, find the intercept and then calculate. Okay, now, okay, using the equation in the equation 5 here, okay, equation 5 here, okay, you calculate the concentration of the sample. So from the equation, okay, the concentration of the analyte in the sample is equals to CS. Okay, CS actually in here is represented by the concentration of added standard, which in this case is the stock. Okay, stock that represented by B1 and multiply with B12, which in this case is the intercept. Okay, CS times B, B is the intercept, and then divide by N, slope value that represented by B11, and then multiply with volume of sample represented by B2 column. Okay, so from there we will get the concentration. Okay, concentrations of okay, in this example, which is iron, okay, in the 10 mils of water. Okay. Okay, I would like to highlight here, okay, the concentration that you obtain either using the calibration curve from the with the x-axis as in the unit of volume, or in the units of concentration. Okay, you can see that the concentration value is similar. Okay, from the calibration curve with the x-axis as a concentration, we get 7, and then from the volume we also get 7. Okay, so from here, okay, another one I want to point out also. Okay, if you using the second method in here, that means if you're using the calibration curve with the x as the volume, okay, please remind that the concentration that they obtain from here is the concentration in the real sample already, because you put 10 ml. Okay, so that means you don't need to multiply with dilution factor, which you did when you construct the calibration curve from the unit concentration. When the unit you get from here, you have to multiply with dilution factor, because the unit in here actually represented the concentration in the diluted sample, which in this example is in 50 ml here, not in here. So, okay, to remind again, if you use, okay, if you calculate, okay, the concentration of analyte using calibration curve with x-axis in the unit of volume of standard, okay, you will use equation, which is 1, and when you use the equation, you no need multiply the concentration obtained with dilution factor, because the formula itself it has to consider the real volume in the sample. And if you determine the concentration of the analyte using the calibration with the x-axis in concentration unit, okay, you need to extrapolated the line, okay, the regression line, okay, with the y equals to 0, okay, where at this point the magnitude that you obtain, the value that you obtain actually represent the concentration of the analyte in the diluted sample. Okay, because of that, we have to multiply with the dilution factor in order to get the real concentration in the samples. Hope you can understand from this video, and thank you.